The question says about larger and the smaller diameters of the differential axle that is 80 mm and 70 mm. The effort is applied to the wheel at the end of the lever whose length is 120 mm long. What is the velocity ratio? Next is based on the above data, that is efficiency and frictional effort lost needs to be calculated when the load that is being lifted is 88,000 newtons and effort applied is 320 newtons. So for this loading situation, it is required to calculate the efficiency and frictional effort that is being lost. So first is that let's compute the velocity ratio. So velocity ratio needs to be computed, which is given by VR. And first the diameters of the differential axle, that is, let's say D1, bigger diameter is 80 mm and smaller diameter is 70 mm, and VR in this case is equal to, that is 2 times of diameter of the input, that is where the effort has been applied, divided by the distance moved on the output side, which is D1 minus D2. So capital D will be equal to 2 times of the length of the lever, that is 2 into 120, which is 240 mm. So upon substituting the values, 2 into 240 divided by 80 minus 70, which is equal to 48. This would be the value of velocity ratio. Next is, let's calculate mechanical advantage. So load that is being given as 8,000 newtons and effort is equal to 320. Mechanical advantage will be equal to load by effort, which is 8,000 divided by 320. So upon calculation, this we would be getting approximately as 0 and 0 is cancelled. This is 8 hundredths and this is 8 fours and this would be 4 ones and this is 4 25s. So mechanical advantage will be equal to 25 for the given situation, and frictional effort that is being lost. Frictional effort, let's say it is F subscript A, so which is equal to actual effort minus ideal effort. So actual effort is 320, ideal is W by mechanical advantage, or it is velocity ratio which is predefined, not for the given instant. So this is the mechanical advantage for the given instantaneous value when the machine is loaded. So this is W divided by velocity ratio. So this is 320 divided by W is 8,000 divided by velocity ratio is 48. So upon calculating, this is equal to 320 minus 8,000 by 48. So this is approximately equal to 167.33. So upon substituting the value of frictional effort will be equal to 153.6 newtons.